we're going to uncover a compound that's natural, that basically beats out metformin and rapamycin, hands down. So get ready. Here we go. It starts off with this veterinary doctor, Dr. Stephanie Van Watson, who was head of the U.S. Navy Marine mammal program, where they had big brain dolphins. You can only guess what they were using those for. Anyway, and she was noticing that she had pods of these in Florida, and there were pods in California. And the Florida pods had much less disease, were living longer, and were much healthier. So she started trying to figure out what was the difference. Why did these pods differ so much? These animals were all on all fish diets. And what she came upon in her research was that there was a compound that when this compound was present at higher levels in these mammals, they lived healthier and longer. This compound, C15, yes. This compound is believe it or not, an odd chain saturated fat. Yeah, saturated fat. Remember the stuff they told us not to touch, not to eat, stop drinking whole fat milk? Well, it occurs in whole fat milk. And I don't say go drink whole fat milk. You don't want to drink whole fat milk because the proportion of C15 in whole fat milk compared to C16, which is pro-inflammatory, is high. Okay, so it's gonna wash out big time. Okay, so don't do that. But it is in milk, in whole milk, or dairy products. So when we uncover this, when we look at C15 and its implications, and I'm going to put it head to metformin, which we know. I don't take metformin. I was taking it a while, and I told you why in my other episodes. And the reason is because metformin, in short, real dirty, just limits the oxygen to the mitochondria, making it malfunction, and then in that turn triggers the mTOR, AMPK pathways, okay? I don't want that because I'm training. I'm working out. I'm lifting weights. I want muscle synthesis. I want protein synthesis. And this is going to basically dampen that. So rapamycin was like the thing. Rapamycin, and both of these are prescription drugs. Rapamycin, there's a Pearl study going on, which is also a longevity study, which we'll have some. But rapamycin is geroprotective, and which means that it's protecting us against all the diseases that we get with old age. And it's very effective at this. So rapamycin is the king up to now, or up to recently. Now, it's been a long time since omega-3 fatty acids, ALA, EPA have been discovered. A long time. So the C15 in the view of things is very new. And it comes from saturated fat. Yes, saturated fat. Remember the fat they told us to stay away from? It's seen in whole milk, fatty whole milk. But it gives us a clue. And the other thing is our microbiome is able to produce some C15, but not at the levels we need. All right, 15 is off the shelf. It's a natural product. And that's probably why you're not hearing a lot about it. So let's look at what it does. What does it do? C15. Straight to it. We're looking for C15 cardiovascular health, decreased risk of heart disease and heart failure, and decreased risk of myocardial infarctions. That is huge. That is huge. Cancer protection. Yes. Proliferative effect on various cancer cell types. Various. Liver health. Remember non-alcoholic liver disease, thing we're seeing a lot of, fatty liver. It reduces fatty liver. It benefits the primary cells system relevant to this non-alcoholic liver disease. Amazing results with liver. It slows aging. How does it do this? It triggers longevity signals. What are those? It triggers mTOR, AMPK, PPRA. Don't worry about these. These are all key indicators that longevity is happening. This slows down the aging. It inhibits mTOR. As we age, mTOR keeps coming up. It goes up. Reason is it's noticing that our body is losing muscle mass. It's more difficult to do protein synthesis for the body. So AMPK goes, the mTOR starts jacking up, going, listen, we need more of this. When that happens, when it does it overly, it's a problem for us. All right. So it brings it back to level. This is huge. And I'll go over this one more time later on. It mitigates COPD and decreases Alzheimer's disease. That's big. That's big. This is C15. It's a fatty acid, C15. So what are the triggers? What's happening? We see autophagy. So we have less zombie cells to no zombie cells. It's anti-inflammatory. It improves our mitochondrial health. Cellular energy goes up. Glucose metabolism, better. So you know what that means with diabetes, pre-diabetes, diabetes 2. Lipid metabolism improved. and anti-cancer. So what markers do we see in our cells when using this? We see a decrease in cholesterol. We see increase in insulin sensitivity. We see a decreased risk of impaired fasting glucose. We see decreased liver enzymes, decreased risk of high blood pressure, decreased BMI, that's your weight, decreased C-reactive protein, inflammation goes down, and adipokines decreased. So it is really amazing what this natural thing, and we've been looking far. We've been looking at genetics. We've been looking at the pharmaceutical industry with rapamycin, with metformin, all the way to Easter Island to find this. And here we are. This thing is closer to home than we've ever thought possible. It was right there, but we threw away a while ago. We decided, as the medical community, listen, this saturated fat, bad for you. Don't touch it. So we threw the whole thing out. We didn't look at specifics within saturated fat. That's where C15 was hiding. But it gives us an indication, and I'm going to put up a chart, the effects on cells comparatively, so you can see how much more effect this has than, rapamycin is pretty close. The rapamycin is a pharmaceutical that you have to get a prescription for. It's super expensive, and this beats it, hands down. Metformin doesn't even come close. So, yeah, is this exciting? This is super exciting. If you're interested, and you should be interested, because this is the next molecule. And let me tell you, anything beating this, I'll bring it up. It'll be on my episode right away. But as of now, nothing's beating this. So get to it. Today we're going to have an update on pentadecanoic acid, better known as C15. Well, guess what? Science and the medical profession threw it out, so-called bad fats. Saturated fat is considered less beneficial for our health. But in that saturated fat, there was one molecule, a fatty acid, C15, which had amazing benefits, and we're just discovering this. So today we're going to go over and see what this new compound has to offer, what the latest human studies tell us about pentadecanoic acid. And C15 is just a supplement, and I say just a supplement because you can buy it off the shelf. I'm going to tell you the supplement, I'm going to show you the supplement, and we're going to look at how relevant this is to cell-based activities with leading to longevity. It's an important compound. California, San Diego, is actually investigating the effects of fatty 15 as pure form of C15 to further validate its potential benefiting cardiometabolic, immune, and liver health. And there's different trials. There's different human trials going on right now. So that's what I wanted to discuss, the human trials, the evidence where we see that when C15 is elevated, people have less problems with cardiovascular disease, type 2 diabetes, their weight, and also they live longer. So we're going to go right into it. Dr. Schwimmer just posted his results from a study that he did on 237 children and found that higher levels of C15 in their blood concluded and basically saw in this study that these kids had lower levels of fat in the liver. So fatty liver disease now affects 10% of US children. It's becoming a big problem at a younger age, which it shouldn't. So this one is very promising. Okay, I'm going to put up my first chart, and that's just foods that we see have the C15 in them. For 100 grams of this food, C15 in milligrams, okay? And we know we need to be around 100 to 200 milligrams daily. So if we look at this gram, we see salted butter, 830 milligrams, cream, full fat, 450, cattle, 410, cheese, cheddar cheese, 390 milligrams, sour cream, 350 milligrams, cheese, lentil, 350 milligrams. Secondly, we're going to go and look at ferroptosis, okay? Now, this is a new way of cell death. We didn't know this, okay, this till recently. And how does this work, and how does C15 work? So we're going to go into kind of the process of this. So here's the next slide, which is how ferroptosis accelerates fatty liver disease, type 2 diabetes, and cardiovascular disease. Okay, so we're going to go through it. First thing we'll see is a fragile fatty acid in the cellular membrane. So it's all about the cellular membrane. And C15 basically, is a very strong chain. This actually strengthens our cellular membranes, whether it's red blood cells, whether it's every cell in the body. So that's one. When we have a fragile cell, because we have fragile fatty acids in the cellular membrane, we get a breakdown, and then we get lipid peroxidation. Okay, this is where the lipid starts oxidizing. Third, we have intercellular iron, and this is ferroptosis. This is where ferroptosis starts. Okay, then we have massive ROS, which is reactive oxygen species, and this creates the inflammation in our body. This creates the inflammation in the cell, and we know when we have inflammation, it wreaks havoc. Okay, so together, what we're seeing is an attack on the mitochondria and cell death, and that is ferroptosis. Ferroptosis is cell death, and that's why I said in the beginning of the program, ferroptosis, if you're not shielded with C15 on your cell membrane, it's over. It's game over. So how does this process work? Well, we got systemic lipid peroxidation. So we got three things happening here. Systemic reactive oxygen species being created and systemic iron overload. Now, don't get me wrong, we need iron. Okay? Iron deficiency is a huge problem. This is not the same. This is when the cell membrane breaks down. When the cell membrane is weak, then we've got this whole new process happening, and it includes iron. So what we're seeing with the liver is iron overload, fragile lipid peroxidation, insulin resistance goes up, and we accelerate the fatty liver disease and NASH. With insulin resistance, we have accelerated type 2 diabetes, decrease of insulin secretion by the pancreas due to the same system, same three things that are happening in the cellular, on the cellular level. And so you can see that all of a sudden the whole system starts breaking down. And finally, the heart. We got direct cardiac tissue injury, worsening vessel inflammation. So when vessels inflame, like even if we have high LDL, even if it's bad LDL, if we don't have inflammation, no problem. If we have inflammation, then we got a problem. Then it's going to start reacting with the cell wall and creating plaque. So we've got worsening of the LDL, so we got more bad LDL coming in, which accelerates coronary heart disease, heart failure, and atherosclerosis. So this is the pathway. This is what, and we'll go deeper into this. This is the pathway that we want to avoid, and this is what kind of, the description of the pathway of ferroptosis. So we want to avoid this, and ferroptosis really has been recently discovered. So we need to be able to counter this. How do we do that? Like I said before, prior to this discovery of C15, which came 90 years after the discovery of omega-3 fatty acids and linoleic acid, omega-6 fatty acid, the evidence that C15 is an essential fatty acid includes these four parameters. One, dietary C15 intake is directly and reliably correlated to circulating C15. Now this has been documented. This has been researched so that when you do take it, it actually elevates the level of C15 in your body. So, important to know. So we know it works. That's one. Two, people with low C15 concentrations consistently have higher risk of developing type 2 diabetes, cardiovascular disease, and non-alcoholic fatty liver disease, which we know is detrimental, or NASH. C15 supplementation effectively raises circulation of C15 concentrations and attenuates components of type 2 diabetes, cardiovascular disease in relevant animal and human models. C15 has a dose-dependent mechanism of action. At concentrations, it consists with circulating C15 levels which directly target type 2 diabetes, cardiovascular disease, fatty liver disease. These C15 mechanisms of actions include AMPK and PPAR alpha activation. So, combined, these studies show that C15 is meeting the criteria of essential fatty acid. Now, C15 deficiency, what happens? Red blood cells membrane with the total fatty acid starts breaking down. We get increased red blood cell fragility and lipid peroxidation, which causes macrophage, erythrophagocytosis. We get the Kupffer cells, iron overload, same thing we went through, ferroptosis in the liver, type 2 diabetes, NASH, cardiovascular disease. And what we're seeing is when C15 deficiency in systemic cell membrane, systemic cellular fragility, and lipid peroxidation. This is what happens. This is what I showed. Systemic ferroptosis accelerating aging. We don't want that. Systemic iron overload, neurodegenerative disease, and inflammation. So this is what we're seeing on a cellular level. And so we really need to look at this closer. We need to keep an eye on this. And I myself am starting to use it, have started using it, because I think the evidence is there and it's clear.